Purpose of this video is to work demo number 2, lesson number 7, and this is the final video of STAT1800. And I'm going to tell you what, as my grandmother would say, it's going to be a doozy. I have no idea what a doozy is, but I assume it means it's hard, difficult, challenging. All right, let's get to it. Again, this is going to be challenging. You can see I missed one right here. I committed a typo like 2 times in a row, and then I counted it wrong, and I just didn't feel like doing it over. So we'll talk about that when we get there. I may end up having to split this into 2 parts. I hope not, but if I do, then whatever. All right, so number 1, this is an interesting question. Okay, so let me bring this up. I'm gonna need this, and let me turn the light off so you can see it. All right, and another way of thinking of R squared. Now remember, R squared is the percentage of variance in Y that is explained by the regression or variation in X. You just got to write that down. If you have to replay this a couple of times to get it written down, do so. That's one of the great things about having the instructional videos. You can replay. You can, if you're in class and I say that and you don't get it down, then there could be an issue. Again, R squared is the percentage of variance in Y that is explained by the regression on X or the variation on X. Now, another way of calculating R squared, and I just want you to have this on your radar. This isn't going to be on your exam. This is not going to be on your midterm. No, I'm sorry. Well, it'll be your final exam now. Not going to be on your final exam. But R squared can be calculated by taking something that's called sum of squares total. No, it's not. Over sum of squares total. So sum of squares regression divided by sum of squares total. Now, I used to teach all this in STAT 1800, but that was back when our class was 5 credit hours instead of 4 like it is now. So, when we reduced the credit hours from 5 to 4, we had to get rid of a few things, and this is one of the topics. Be glad. It's kind of confusing. But nevertheless, I want you to have on your radar that R squared can be calculated this way. So sum of squares regression is SSR in this problem, and the sum of squares total is 96. So if you take 94 divided by 96, you get 0.25. Now the meaning, as I said earlier, it's just R squared times 100, so it'd be 25% of the variation in the dependent variable can be explained by the variation on the independent variable. So here we are testing the null hypothesis that there is no relationship between the 2 variables, sample size 10, correlation coefficient is equal to 0.5. So that R equal 0.5 is the correlation coefficient. So the first thing we do is we select the appropriate null and alternative hypotheses. So the null hypothesis is that rho is equal to 0. Remember, if we're testing mu, we use x bar. If we're testing a proportion, p or pi, we use p hat. If we're testing a statement about a correlation coefficient, the parameter value is rho, and the sample estimate is r. So again, we're testing rho equals 0 versus rho not equal to 0. Now, the test statistic for the calculation of a correlation coefficient is kind of nasty, but it is what it is. So it's r minus rho divided by the square root of 1 minus r squared over n minus 2. So what we have here is r in the problem is given as 0.5. And we have our null hypothesis that we're assuming that rho is equal to 0. Make this square root very large because we've got a lot to go underneath it. And our sample size is n minus 2, so it's going to be 10 minus 2, so I'm just going to go ahead and put an 8 there. So what I have is I have 0.5 over the square root of 1 minus 0.5 squared over 8. Now, I'm going to show you the way that I would do this. You do whatever turns you on here. I'm just going to tell you the way I would do it. If I were working this, let me get this where you can see it. I would go the square root of 1 minus 0.5 squared. Close that up. Divide by the 8. So again, I need everything under the square root. You're going to get the wrong answer if you don't do it that way. Everything, the 1 minus 0.5 squared divided by 8, all that has to be under the square root. If not, again, it's going to be wrong. So when I do that, I get all of this stuff down here. But then I need to take 0.5 and divide it by the answer. And when I do that, I get 1.63, which I have entered as the answer. All right, let me do a little housekeeping here. Now the next part is I need the lower critical value. So I'm going to go to STAT, going to go to T. I need my degrees of freedom to be n minus 2, which is going to be 8. And I have a level of significance of 0.05. So that tells me that I need 0.05 divided by 2 in the left tail, designated by the less than. And I hit compute, and I get negative 2.306. To get the upper tail, I could just change it. And get the positive for that, or I could just note that the lower critical and upper critical are always the same value, just one is negative and one is positive. So my test statistic is 1.63. It's between my two critical values, therefore I would fail to reject H sub O. All right, an attempt to develop a model of wine quality. Cool. I like wine. Okay. My wine expert, actually, I don't drink much wine, but sometimes I like it. Alcohol content, particular wine. So we have 17 wines in the sample. A model was used. So we're taking the percentage of alcohol to predict wine quality. And this is an interesting question because we have the standard error and B1 given. All right, so I'm going to need this. So the test statistic here is just my estimate of B1 over the standard error for B1. So really all I need to do is just take 0.4475 and divide it by the standard error, which is 0.1528. And so 0.4475 divided by 0.1528. And you can see that I get 2.93. Now to find the p-value, I need to go to my calculator. Get rid of this. So I have degrees of freedom 17, so minus 2 is 15. Now, let me pump the brakes a little bit here. If you remember back when we were doing a t-test, we were taking like H sub O equal, or H sub O colon mu equal 12. The degrees of freedom were n minus 1, right? But we're doing a different type of test. This is a completely different tool in our not to get goofy here, but in our bag, our toolbox, of statistical techniques. This is a different tool. It's kind of like, straight screwdriver versus a Phillips screwdriver. So for this type of test, our degrees of freedom are just different. It has to do, there's two regression coefficients that are estimated. So we have to take away from the degrees of freedom because of that. So anyway, just remember for these types of problems, the degrees of freedom are n-2, not n-1. Now I need the area in the either one, the right tail or left tail. So I'm going to just do the right tail, so 2.93. And since I'm doing a two-tail test, I need to multiply that by 2. And you can see I get 0.010. Now, my alpha value is 0.05. So my p-value is less than alpha, so I'm going to reject. So there's sufficient evidence to conclude there's a linear relationship between the two variables. All right, next thing I need to do is calculate the 95% confidence interval. I absolutely love this problem because it makes you think in general about what's going on with the confidence interval. Remember, as I've told you before, there is an estimate plus or minus a critical value times the standard error. All this stuff over here is called the margin of error. So our estimate is going to be the 0.4475. Our critical value, we don't know that, so we got to go grab it. It's going to be easy to do, though. Go to calculator, go to T. We have degrees of freedom n-2, which will be 15. I'm testing at 0.05. Well, I have a 95% confidence interval, so I need 0.025 in one of the tails. Calculate 2.1314. Now, people often ask me, well, do I put the positive or negative variable? Well, you're putting them both because you have plus or minus. Standard error is 0.1528. So if I can put that in my calculator without doing something crazy, I'll share it with you in just a second. So there's what I get for the bottom. Just let me show you what I did. Just typed in the numbers. And I used parentheses to designate the right side. So now I'm just going to change that to a plus. And I get the upper bound of 0.773. All right, question 4. So we have a model that was used to calculate mileage. To predict price based on mileage. So what's the explanatory variable? That's the variable that explains the variation in price. That's the X variable. That's the predictor. So mileage, because it is used to predict. So whatever is used to predict is called your independent variable, your predictor, your explanatory. Your response variable is always your Y. So in this case, it's going to be the price. The interpretation, the slope. So used cars lose because we have a negative slope, about 110. So we multiply that by 1,000 because they are going according to 1,000 miles additional on the odometer. The y-intercept is the 21,250. So that's not going to be very meaningful here because there are population of cars under study are used cars. And if a car has 0 miles, then it's not considered used. So What would you, the predicted for 75,000? So I'm going to put 75,000 in my model. So I'm going to type 21,252.33 minus left parentheses 75,000 times 0.11032. And I get a predicted value, what I entered. Now, next thing we get into is we get into a residual. And I taught that in a previous video, but just the residual is just the observed Y minus the predicted Y. So the predicted Y in this case for a car of 75,000 is 12,978. Now the next question says if the price for a car was 75,000 on it was 14,000, so that's what we observed. So our residual is positive. What would the residual be? Well, I just take 14,000 minus 1278 and I get, well, I used the 12,978. Let me put that. And I got 1,021.67. So what's happening is the car is actually selling higher than it was predicted to sell based on the mileage. Okay, so I think this is a bad deal because the observed is greater than what we predicted it to be based on mileage alone. Now we all know that there are more variables in predicting, explaining the price of a used car, you know, the shape and the color and the interior and the, you know, all these different things. So you can tell I've never sold cars. All right, next thing we have a correlation match. So what I did is part A, I knew that was a negative correlation. It had to be the one with the highest absolute value. Well, that was clearly negative 0.977. I knew that this correlation for D had to be positive. It had to be the highest positive. So that made it 0.77. I knew that B had absolutely no linear relationship whatsoever. So the R value had to be extremely small, close to zero. And the one closest to zero was 0.006. So I paired it with B. And then C, we have a slight negative relationship, but it's kind of a moderate. So it was the only other negative of negative 0.487. So that's the way I worked that one. Now, embarrassingly, here's where I made a mistake. And I just made a typo 2 times in a row and just didn't feel like doing it over. So let's click on a scatter plot. And I really like this question too because it, let me make this larger here. Because it gives you an output. It makes you think about, in general, what's an output look like for a regression analysis. And notice it gives you the R squared, then it gives you something called the standard error of the estimate, and then it gives you the intercept and the slope. So it gives you the B0 and B1 right here. And then, of course, it gives you the scatter plot. So the growth is our Y. So the intercept, and I know the growth is a Y because I look at the Y-axis, right? GDP is the X. So I have to choose a one with leading country as my X and not regions country, which, so is automatically it's going to be A. The slope is 0.535, which I get from right here. And then the intercept is 0.370, which I get from there. I'm not going to go over the intercept. Well, I will. The intercept is the predicted growth when there's 0% growth in leading country. So yeah, there could be a 0% with a negative GDP growth. So that was my selection there. The interpretation of the intercept, I chose selected the GDP in the region increase 0.535 because that's what the slope is for every 1% increase in growth in the leading country. So that's the X variable. In a year in which the leading country grows at 0%, what's the predicted? Well, it's pretty obvious. It's the intercept. Put 0 in here. You get 0 times 0.535. It's just 0.370, so I just entered 0.370. Now, here's where I felt like a bozo. I could not, for some reason, type this 1.65 incorrectly. I'll prove to you that I can. So in 2010, the leading country experienced a 3.02 growth, while the nation's country grew at a rate of 1.65. So what I need to do is put 0.3 or 3.02 in my model. And I'll share this with you. So I entered 3.02 in the model, and of course I get 1.986. Again, I felt like such a bozo. I have no idea why I couldn't type 3.02 in my calculator, given two opportunities, right? That's what's most embarrassing. But I didn't, and I just didn't feel like doing all of this question over just for that. So the residual is going to be the difference in the observed, which is 1.65, minus the predicted, which is 1.986. And when you subtract that, you get negative 0.336. Okay, that's it. All right, take care. Let me say one thing. This ends all the videos and it ends the demos. So how will your demo grade be calculated? If I counted correctly, you have had 65 demo questions. Let's say you scored 64 out of 65. Well, I'll turn that into a percentage, 64 divided by 65 times 100. And that will be the grade that will go in for your, calculate your final grade for your demo video portion of the final grade assignment. I consider this to be bonus points. So don't even think about emailing me and saying, Dr. Darbro, what can I do for extra credit? Well, you're getting it right here. It doesn't get any better than when your professor works the problem for you. And all you got to do is select the answer and type in the right answer. So this is extra credit. This is equivalent to one assignment and half of an exam. So, I think it should be a grade booster, and you should have taken advantage of this opportunity. And I'm sure many of you did. All right, that's it.